Good morning. Welcome back to the course. I am Dr. Amandeep Singh, and I will take the plant simulation technomatics in this lecture. So, we have discussed about the plant, we have discussed about the simulation, we have discussed about the product design and manufacturing aspects. So, in this lecture I will just touch what is the kind of the simulation that we do in designing a plant, and how material is being carried from one point to another, all those things, what kind of simulation we can do there. So, before moving ahead, I will just like to give the contents here. The contents will follow like this. First I will discuss what is PLM. PLM is product life cycle management. Product life cycle management. Then I will just go to my plant simulation software, which is plant simulation 10, that is technomatics. Okay. Then we will just discuss the software. Another software, Arena, is similar to this one, but plant simulation or the PLM software that we have here is in IIT Kanpur, that we have is the Siemens PLM version. So, this is the kind of an very advanced version. Arena has an extensive use in research and in actual application in industry, but this plant simulation, if we talk about the software, there are two major functions. One thing is specifically simulation for software, one thing is the functionality. The functionality, what is the function that software is able to do. So, how intelligent is our software to design the systems. Second thing is the aesthetics or appearance. In this case, in the plant simulation software, I will show you that the three-dimensional movements can also be seen. The aesthetics are splendid in this case. So, we can see the workers taking the material, we can see the movement of the materials, all that animation kind of thing is there. So, that is the kind of an, I can say an add-on, but the capability of this software to simulate using different distributions, using even we can have energy simulator to minimize the energy used in the plant, or also we can we actually calculate the throughput or the total output that is of a day or of a month, and during the day or during the month, what is the total cost that is incurred, the cost of operating, the cost of processing, all those things can be done. So, let me move forward. So, what is product lifecycle management? Product lifecycle management is the system of strategic processes which are employed to reduce the cost of getting a product to market. Okay. It is a system of strategic processes, I would say. You know, these days we need to extend the duration of the profitable years of the product, because the product, if we talk about the product life cycle is something like this. Not from marketing perspective, I will talk from the development perspective. Product life cycle is, if I say, okay, this is my profit, okay. So, this is I would say rupees, and this is plus rupees, and this is minus rupees. Okay. So, it is, if I divide it into stages, when I am planning and I am manufacturing, then I am building the product, then I am trying to provide after sales support. So, this is not the marketing kind of product life cycle that I am doing. Marketing kind of product life cycle is just like this. We have growth, then we have first we have introduction, then we have growth, then we have maturity, then we have decline, and also some decay could happen. So, this is marketing perspective. So, I am talking from the product development perspective, from the very design. When we design a product, we are talking of the product design and the simulation in the systems. So, when we design the product, during design itself, the development perspective is taken into account. Actually, this kind of curve which I am going to draw, this is the curve like this. It was something like this. Okay. Initially what happens when we are planning, this is the planning stage, second is the manufacturing stage, then we have the manufacturing can be extended, then we have before manufacturing, okay, I will put manufacturing at third point. Before manufacturing we have development of the complete plan or the development of the maybe prototype of the product. So, after manufacturing the product is sent to the market, then we have after sales support. Okay. So, what happens, we need to minimize this and maximize this. You know this curve, that is, this is my 0 value, that is below the 0 line, this is kind of a loss. Okay. So, this is, I can say, this is here I can say the milestone, this is the launch of the product. Okay. I can have break even point here because that investment that is made is covered here. So, this is break even. So, this is the peak profit that we have reached and the product retires here. So, what is the life cycle of a product? For instance, you purchase a new mobile like Samsung Note 9 is there in the market. Where does Note 8 go? Where does Note 7 go? I had been using Note 2 since last year. So, where does that go? That has completely retired. The new version of the product has come. So, the life cycle of a product of one specific segment in case of this electronics or maybe mobiles is about an year, or maybe it has even reduced, contracted than an year. It is about 6 months, 9 months sometimes. So, this is final retirement of the product happens. So, what PLM, if we use PLM or product lifecycle management software, what happens? This is reduced. This is reduced and this is maximized. You know, this peak is I would better say peak is attained earlier than the normal design. Okay. Then product launch could happen even before, break even is achieved before. So, this is the kind of a profit or the kind of a contraction in the time that happens using the software, because when we are doing the simulations, you know, it is better to fail a simulation than to fail a factory. It is a very common course that is said. So, when we do simulation, when we design the product, we can do the kind of testing. So, if I am talking about the product, if we do planning here, the product for instance, okay, if I need to design, okay, this mouse, if I need to design this mouse, I need to have the specifications, or I can just scan this mouse and get the point cloud and then the triangular mesh, and these are mechanical terms to get to do some analysis that whether the strength of the material, which kind of material would I use, all those things can be done in a software. So, in that simulations happen. So, that is a kind of a mechanical simulation. So, we can even call it, if you heard of the term computational fluid dynamics, that is a kind of a mechanical simulation. Then certain multiple modules are available for many softwares in the market, but because we are talking more about the product design and manufacturing and we are not talking about the systems design here. So, I will focus more on technomatics, that is the manufacturing, the development or specifically the manufacturing part. Okay. So, about this curve, this is here we have speed to market, that speed to market that it has reached the market before, then productivity is boost, you know, the slope of this curve is higher, this curve the slope is higher, okay, the slope is greater. So, there is a boost in productivity, there is an increase in revenue because peak is here, right. Then we have the extended returns, the retirement period is now we get retirement at a later stage. So, this is what product life cycle management, if we actually do the product life cycle management, life cycle means not only designing the product, managing the overall or the complete life of the product, from the very idea generation when we have an idea to produce a product to the final retirement of the product. Retirement means when the product would just kind of obsolete and new product would take its place. So, about the software I would say we have in PLM Siemens software, this is, we have these 4 stages. This part is done by NX. NX is a kind of a CAD software. Okay, it is CAD and CAE. CAD is computer aided design, CAE is computer aided engineering. Computer aided design is with just design, like I said, I will design this mouse, this specific product. I can, if I need to have the specifications, the specific curves I need to draw, and I can design that is computer aided design. Then I can do certain analysis, certain testing on this, okay, which are the critical parts, and what would be the life of this plastic portion. I am not talking about the internal body, I am just talking about the cover of the mouse here, okay, that is computer aided engineering. So this is NX software used. We would more focus on the development and manufacturing, that is done using Technomatics. Okay. Now this is again Technomatics. Okay, this he will use the plant simulation 10 software here. When we have designed the product and we know what are the processes which this product has to follow. For instance, this is the product, they have different components. If I dismantle it, this cover, this roller, the base, there are certain nuts, and this is a cover at the bottom, the cell is there, okay, the cell is an external component. So I have different components which are to be manufactured. So for this I need to have plastic manufacturing machines, like maybe molding machines, or extrusion, injection molding can happen, all those things. Extrusion is not required, although like we need to have the machines. Now how to set up those machines in a plant or in a factory, that is known as plant layout, okay, that I will also discuss here. So this is Technomatics, and the final support, that is done by Teamcenter. Okay, so this software has major 3 versions. Number 1 is NX, number 2 is Technomatics, and number 3 is Teamcenter. Okay. This complete version we can call it as an ERP, an enterprise resource planning. Okay, so this enterprise resource planning, Teamcenter is more focused on ERP, but yes, we can say that complete enterprise resource planning can happen, and we can even simulate. The simulation happens more in NX and Technomatics, and in Teamcenter what happens, whatever we have manufactured, the cost which have incurred for manufacturing, and if we need to change something, because you know this is planning, and the planning and the actual production, there is a difference. When that difference happens during actual manufacturing, when we are actually doing the manufacturing, the data is all stored in our different formats, okay. Those are used by the Teamcenter version of the software. The data is stored in different formats, so that can be used, those formats which are available in Teamcenter, and Teamcenter we can just modify the data according to the actual which is happening, though not the schedule, the actual manufacturing. So those then the simulation can be run again sometimes, like to see whether what we have planned, are we achieving that or not. So what is the variation? So you know some variation would always be there, and those things, it has an extensive application. Arena is a kind of a software which was just confined to the plant simulation only, but this PLM, Siemens PLM, I am talking about Siemens PLM software, okay. So this can work in all these domains. Now I will move to the software which is a Siemens PLM software, which is in the SSOL lab. SSOL is Smart Systems and Operations Lab, which is there in IME department, Industrial and Management Engineering department at IIT Kanpur. So the software is installed in the systems in the lab only, we have server in the lab only. So we cannot have the software on this, but I am using that software using remote access on this computer. So I will just open. So remote access connection is already made. So this is my computer which is there in the lab, and I will open my software. I will go to all programs, and I have Technomatics here, and in Technomatics I have plant simulation, and I will open the software. Okay. So, this kind of window appears when we just open the software. These are the certain programs which I have just worked on. So, the recent programs are there. So, this is the start page. Okay. So, I can open or I can create a new model from here. So, I have a menu bar here. In menu bar also I can open the new file, I can open the existing file that we have. So, in also we have another this tab here, we have these icons for opening. So, I will just create a new model. When I click to new model, the new model is trying to open. Yes, okay. Now, it has basic objects here. The basic objects which are there, these would be enough to discuss in this lecture. We have a limited scope and time here. So, basic objects whatever it has selected, I will just say yes to them. However, there are multiple models that we can select here, as we can select certain, so there is big library and I can select the 3D or this, you know, this is AGV, automatic guided vehicles, then 3-dimensional conveyors, 3-dimensional robots, conveyors, all those things. But I will stick to the basic selection, whatever it is, default selection, apply. So, the model is opened. So, this is the model frame. This is workspace where I will work, and there is a grid. The distance between any 2 points here, the horizontal or vertical distance is 1 meter. I can just switch off and on the grid from this icon, this button here. Okay. It hides or shows the grid. So, these variations I will show later. So, this is my class library. I am just clicking it to bring my icons here. Okay. So, these are the components. Before actually starting the model, I will like to show you what is the, I would say, the potential of the software. So, I have one example here. This is the car body manufacturing in 3-dimensional. Car body manufacturing. Okay. So, this is an example in which whole factory is built in the software, and also the General Motors had built one of its new plants using this software, and they have reported that 50% of the savings were there in the development part, because they developed, they tried to simulate the movement of the objects and the times and all those things, and what actually they were trying to do in manufacturing, they are able to see that in the software, like the animation. Okay. So, this is my event controller. So, I like to show you how the manufacturing happens. You know, this is you can see this is actually moving very fast. I control the speed, you know, workers are moving in very fast pace. It is the fastest speed. So, I can control the speed using event controller. Let me stop it and let me say, okay, the speed is real time into maybe 5 times, or maybe real time into 10 times, apply, okay, then play. You know, the car is coming here, it is then taken by the overhung conveyor. Okay. So, the workers are standing here. You can see workers are doing, they are trying to fix maybe tires, okay, or the tires, the wheels here, or the side mirror. So, the car is completely manufactured, or the accessories are just put on the cars, and those are then sent. So, these are different workers, those are working in different stations. This is the workplace. I will just show the objects when I will come to the actual practice on the software. This is the workplace, work pool where the workers could stand when they are not working, and this is the workplace for the worker. Okay. And worker just picking it from some point. Purple pillars that you can see, these are this purple pillar and this purple pillar. So, these are the workstations for the worker. Actually, this space at the bottom, this is the workplace where the worker is working, and some other processing is also happening. So, cars are just, this is my entry point. This is my entry point. Okay, this is my entry point, and here it is taking a turn, and this is my exit point. So, this is the factory. Okay. I can show you some other examples. So, this is the two-dimensional version of that. Okay, and the workers are working here, you can see. Okay. So, the car is going out, and for some other part, for maybe inspection, it is going. So, I will just close this model, and I will come to my start page again, view, from view come to start page. So, this is how we can see, or I can just pick, let me open this model. Okay, this is one of the models in which we have used the experiment controller. Okay. So, you can see if I run the model, it has run for 8 hours. In the fastest position, it has run for, because I had put the end time for 8 hours, the model has to run, and I can see the throughput here. Open, it is the drain, complete of the final drain of the, I can see the throughput here. What is the throughput, or what is the total number of components that those are manufactured in a day? This is throughput per day. If you see here, this is throughput per day, 534 pieces, and throughput per hour is 22.25 pieces. Based upon the input that we have given to the specific processes, what are the input to the processes that I will discuss? It is the setup time, processing time, then the availability, is it available for the complete time, or is it available for 95% or 90% of times. Then we have the distribution, we have the specific process, for instance, it is a manual process, and we do not have much data, we have only 2-3 data points which are previously available. So, we can pick maybe triangular distribution. If it is an automated process, I can pick normal distribution with a very less variation, because the process is automated. Based upon the inputs that we give, the software will try to simulate and give us a throughput. Okay. So, any software, when we say the software is here, there is a very common quote that is said, it is GIGO, garbage in, garbage out. Softwares can just help us to bring our overall ideas into one place, and we can simulate the computation that we sometimes try to do on page. Those can be done here, and these the softwares are able to show the animations in a very elegant way. But if the input is not proper, input has to come from the systems manager, from the person who is trying to work on it. So, if the input is not proper, output would obviously be affected, the more errors would come. Okay. So, this is, I just showed you how to see the throughput. So, let me close this one as well and try to make a model for you people, and I will let you know how the model is made. So, I like to stop here, and thank you for being in the course. So, we will meet next time. Thank you.